We've talked about the software development workflow and how it directly relates to the need for source management and why we have Git and other source code management systems. And so we're going to dive into how Git works and how it helps us manage our source code. And I'm calling this the source code management model. And so Git, it is a distributed source management tool, and we covered that in an earlier video. And what that means is that the repository that holds all of our source code and records all changes and modifications of that source code over time can be in multiple locations at the same time and can hold the entire source plus the entire history of change. Now, one of the most common setups for this is using a cloud service, a service like GitLab or GitHub, or if you're in an enterprise world, you might have a local source code server that's on the network that houses a remote repository. So the two big features of the source code management model are you've got the remote server, which could be the cloud service like GitHub or GitLab, or it could be a local server on the network that's run and managed and taken care of by your IT department. And then you have your developer machine. And each and every developer who is working on your project is going to have their own machine. And on that machine, they are going to have a complete copy, or in Git terms, a clone of the entire repository and the entire history of change on that repository on their local machine. And so now, because it's distributed, we have a complete copy of the repository on our remote machine, which is the cloud service or the local server, which gives us safety and security because we have a copy there. And then on every single one of our developer machines, we also have a complete copy of that repository and the complete history. So now we have redundancy, meaning that if any one of those machines, whether it be the cloud service, the local server, or any one of the developer machines fails, a hard drive dies, the computer fries, what have you, we have redundancy. We have a backup of that repository, which means we are not at risk of losing our entire source control as well as the history of that source. This is one thing that makes distributed source management tools like Git extremely useful. And it's why Git has become one of the most popular source management tools out there. Now, on the cloud server, as we see right here, there's going to be the central repository. And in that repository, you're going to have a whole bunch of binary files where the tool, Git, is actually storing, number one, everything that makes up your source, the files, the code that's written in it, all that kind of stuff, as well as all of the branches that you are using to manage that source or manage versions of that source. And we'll get into a lecture further on that's deep into how branching works within your repository. But right now, just know that branches are separate containers that hold separate versions of your software that you want to have in a specific state or that you may want to keep for a long period of time. So in this example right here in this diagram, we have the master branch. Oops, let's go the other direction. We got our master branch. And the master branch often is used as the development branch. In other words, it's the branch that everybody is pushing and pulling code changes to. It's the one where it holds the most recent version of the code that's being developed on. And then you may have a staging branch. Now, this is just an example. In other words, people may have their repository set up completely different, but this is a common method for setting up your repository. And in that staging, this is where you have code from master, where you've reached a point where developers have turned in a bunch of code, have passed off or completed a bunch of different tasks, user stories, or to-do items. And the code is at a state where you want it to get tested. You want QA to really dive into it and make sure it's ready to go to production. So you would take all the code that's in your master branch and it would be copied over into your staging branch. It would be tagged as a certain release version of staging. And then that code would then be pushed out to a staging server for QA. And the way that would be pushed out is you would actually just have a clone of the repository on the staging server, and you would pull from that branch, pulling out that code that was tagged to be sent out to staging. All right. So if it passes staging and QA says it's all awesome and everything is good to go, then what would happen is you would then clone that code over to your production branch. And in that production branch, you would then tag it as a particular release, like version 1 or version 2 or version 2.1. And that code is then recorded as an actual production version of the software. And it's recorded for all time in history in your repository, meaning that at any point in time, you could roll back to that version in your production environment and know that you have a running good state for that code. So that means if for some reason you rolled out some software to production that passed staging and there was actually a glaring bug in it that was missed, you could always go back to the production branch and roll back to the last version that you knew was a good or last known good version of software. And then of course that would then be pushed out to the production server either through Git, and you would pull it from the repository to the local repository on the machine, and then have production start running off of it. Some companies like to use a manual production rollout process where all files are audited by an actual human being, and there's different ways of doing it, but this is just a simplified, easy way of doing it. All right, so that talks about our central repository, or the primary repository that sits remotely on a cloud service or else a local Git server within your institution, within your company. Now, the really important part here that affects you as a software developer is the repository that you have cloned down to your developer machine. And that's the one we want to concentrate on. In the repository that's on your local machine, it is a complete copy of the full repository from the remote server that everybody else is copying from. And it maintains a full history of all changes that have happened to all files and folders in your source code. It also maintains a copy of every single branch that you have. Right here, I did not bring down all of these branches into my example down here, but you do see that this repository has a master, this repository has a master. This repository would also have a staging and a production, but on a developer machine, you're usually not doing any quality assurance and you're definitely not running production code. So although they exist in this repository, we're ignoring them, because on a developer's machine, what happens is you've got your master, which is the one that has the most recent version of everybody's code in it. But as you are working on your machine, the reality is you're not actually working in your repository. What you're actually doing is you're working in what's called a working directory. And so when you clone a Git repository down to your machine, it actually sets up a folder, and then all of the current code from whichever branch you're working in is actually created inside of your working directory. And your working directory is actually the directory off of which you will be editing files using your IDE or your Notepad++, your whatever IDE you're using. It could be Visual Studio, it could be it could be NetBeans, it could be any kind of editor. The editor is actually looking into your working directory, not the repository. And so you're working in that working directory, and it's recording all the changes that you make to your source files while you're in your editor, but those files are not yet being put into your local repository. It's also your working directory off of which, if you're running a local development server, like if you're doing web development, it's that server will be looking into your working directory to pull the files that it needs to run the web application or the website that you're working on, so that you can test it locally on your machine as you're making changes, as you're modifying that source. Now, once you've completed a task and you've built all the code for it and you've tested it on your development server and it's ready to go and you're feeling good about it, what happens is you actually have to still commit the code that you wrote back up to your repository, and it needs to go into a branch. Now, if you're a sole developer, you might be working in master, but if you're working on a team, there's a good possibility that you are actually going to have a feature branch, which is a copy of master, which has everybody's code in it, and you begin to work on just your feature in that branch so that it doesn't impact everybody else if you're writing bugs or if you're breaking stuff, if you're adding or deleting files. And so you're going to be committing to, most likely, a feature branch while you're doing all of your software development and while you're testing. And then once you've completed everything and you've committed everything to the feature branch, then you're going to get into the more complex part where you're going to be merging in the changes that you had in your feature branch. You're going to merge them into master, and you're going to make sure that there aren't any conflicts between what's inside of master, which is from everybody else, and then you're going to fix any conflicts that might happen based on the code that's in here that you got from everybody else. Now, as you're developing, it's a good idea to pull down to your local repository all the changes that people are making to master as they are merging their features into master and committing it to the central repository using the git push command right here. So you're going to pull down all of the code that everybody has been changing while you've been working on your tasks. And as you pull all that code down into master, it's then going to tell you if you have any conflicts between what other people have written and what you've written. In other words, if somebody deleted a file and you were actually putting code in that file and they ended up committing to the central repository before you, when you pull down their code into your copy, it's going to say, oh, wait a second, you have a version of this file that you have been editing, and it's more recent than the version that was deleted by this other user. We have a conflict. And so then you're going to have to try to figure out how to fix that conflict before you can then commit all of your stuff back up to the central repository. And that's where we come down to merging and fixing conflicts between your branch, the feature branch that you're working in, which is usually a temporary branch, and then the master branch, which holds everybody else's code that they've been committing to it. And so the standard process is you pull everything before you start working, you create a branch that's just your branch to build whatever it is you're working on, and it's a temporary branch. You do all of your editing, you do all of your testing, you commit everything back to your branch, and as soon as you feel like it's rock solid and ready to go, you then pull down again from the central repository to make sure that your master is correct and that it has the most recent code from everybody's submits to the central repository over however long it was you were working in your branch. And then it is going to compare your branch and the master branch. It's going to try to resolve conflicts automatically if it can. If not, it's going to mark files as having conflicts. You're going to have to go back, look through it, maybe talk to another developer about the changes they made that affects the exact same lines of code you changed. Make sure you figure out how to fix that. And since they committed first, it's your responsibility to make sure you fix it and you adjust it, which will require some communication. And once you've solved all of the conflicts that may have happened as you're merging from your feature branch into master, and once everything goes in and everything's good, then you're going to go ahead and if no one has, you're going to pull again to see if anybody has committed to the central repository while you were working on merging. And if somebody has, it's going to again try to figure out if any changes have happened. If they are, it's going to try to resolve them automatically if they don't impact each other. And if there are some conflicts, then you're going to get warnings here, and it's going to tell you what files there are conflicts, and then you're going to have to try to figure out how to fix the conflicts between your master and the central repository's master. And once you've got everything fixed and you do a pull on Git and there's no conflicts between yours and the central repository, then you'll be free to push your repository. And what it'll do is it'll push all of your changes to master, as well as any changes or new branches you created up to the central repository, and it'll become part of the full history of the repository. So this has been a brief overview of a relatively complex setup for Git repositories, both having a remote server or using a cloud service like GitHub or GitLab, as well as how it works on your machine when you are modifying and manipulating source files, and then the nuances of merging branches, adjusting conflicts that happen between your code and somebody else's, and then ultimately pushing everything that you've done on your machine back up to the cloud service or the local server so that it's available to your entire team. And every single developer has to go through this process of making sure that their code doesn't break everybody else's code and that there aren't any conflicts, and that when they push it back up, everything's good to go. And what we're going to do in the next video is we're going to actually walk through setting up Git, setting up an account at a remote server, and then going through the process of working as an individual on a piece of software, which means we're the lone developer, which will happen as you're going through school. You may be the only one working on a particular piece of software. And we'll go through a lone wolf setup, and then we'll go through the process of actually using Git and having two different developers committing to the same repository. And we'll walk through what branching looks like, as well as we'll walk through what it is to fix conflicts between your code and somebody else's before you're allowed to commit back to the central repository.